take this example, pause the video and get the output. Void main float f is equal to 0.6 if f equal to 0.6. Let me write here some print statement for you. Printf hello, else printf hi. Well, pause the video and guess the output. So, we'll see the concept here. 0.6 is assigned to f. 0.6 equal to 0.6 is true. That is the reason answer is hello. That's what people are expecting. Okay, we'll pause this for some time and we'll see another example, and I'll try to explain both examples. Void main. Let me take another variable, float f. Here I'll try to initialize with a different value. Let me put that as 0.125. If f equal to 0.125, and same printf I am going to use, printf hello, else printf hi. Okay. Now we need to find the output of these two programs. Okay, first I'll explain the output. After that, how the output came, I'll explain in the next 15 minutes. So next 15 minutes will be very critical to understand. Okay, here the output is hi. Don't get surprised. Here output is hello. Well, what's happening internally, that we need to do anyhow. Okay, we'll do that anyhow. Now first we'll understand what does it mean. Can you please see 0.5 is what type? People are thinking it is a float type. 0.689, 0.312, 0.516, minus 0.123, 13.456, minus 81.976, 543, 0129. Well, now listen. Any decimal point number by default is considered as double. Try to understand. From starting of our session, we told any decimal point number by default is float. It's not that way. Any decimal point number by default is considered as what? Double. It's not float. Then immediately we have a question. What is the difference between double and float? And second question is, from starting of the class, we are telling it as float every time. Then why we did not have any issues? That we are going to discuss now. Okay. Well, first you need to understand the difference between float and double. Let me explain that so that you will understand it. First, float versus double. Okay. Now, the size of the float is 4 bytes. The size of the float is 4 bytes. The size of the double is 8 bytes. Okay. Okay, fine. Size is 4 bytes, size is 8 bytes. Okay. Next, float is a single precision. Double is double precision. Double precision. Now we have a question. What is the difference between single precision and double precision? Most of the time people are thinking after the decimal point, if there are 2 digits, it's a double precision, 1 digit, then it's a single precision. So some people are thinking this is 5.8 single precision, 5.82 double precision, 5.835 triple precision. That type of things are not allowed to understand. First you need to understand what is single precision and what is double precision, and you need to know any decimal point number by default is considered as what? Double. Then how do you consider as a float? You need to append f. Try to understand. If you write 6.1, it is what? Double. If you write f, float. 6.1, double. See, here after decimal point I wrote only one digit. Here also after decimal point I wrote only one digit. It is, precision is not telling about number of digits, understand. That is very important point. Okay. Well, if you can see here, 6 is considered as what part? Decimal part. Whereas 1 is considered as fractional part. Well, so every floating point number will have two parts. One is a decimal part, another is a fractional part. Or I can call one is a integral part, another is a fractional part. Any decimal point number by default is considered as two types. Any decimal point number by default considered as a double. If you want to consider it as a float, you need to append F. That's what first thing you need to understand. Now we will discuss between what is single precision and what is double precision. Okay, but before going to explain about single precision and double precision, why precision came into picture, I will tell you. Okay, what is the need of precision? What is single precision? What is double precision? If you want to understand, first you need to know what is precision, right? So first I will go to precision, after that single precision, after that double precision, and all other things I am gonna explain for you anyway. Well, now first to understand what is precision, we'll try to convert a given decimal number to binary. Okay, fine. Let us take 0.125. I want to convert into binary. We already know if a number is a decimal number, what we are doing, we are multiplying with if a number is a normal number, we are doing LCM with 2. Here we need to do little small change. What it means, I will tell you anyway. Okay, just see here. First of all, I need to take this and I need to multiply with 2. Whenever I multiply with 2, 0.125 came. Into 2 will give you what? 0.25. Fine. Now you need to take this 0. Okay, fine. Next, what is the remaining 0.25? So 0.25 into 2 I need to do. 0.25 into 2 is how much? 0.5. Now I need to take what? This 0. What is remaining? 0.5 is remaining. Into 2 I need to do. 0.5 into 2 is how much? 1.0. Now we need to take 1. And what is remaining? 0.0 into 2. And I cannot do anything with this, correct? I cannot do anything with this, so not required to worry. Well, so 0.001 is the equivalent value for 0.125. Means to represent 0.125, I need 3 bits. Let us consider, is this valid binary data or not? How do you consider? We were multiplying with 2 powers. Here also you need to multiply with 2 powers with the negative values. So how do you do that? This one 0 into 2 power minus 1. This one 0 into 2 power minus 2. This one 0 into 2 power minus, 1 into 2 power minus 3. Okay, this is 0, this is 0, this is what? Minus 1 into 2 power minus 3. What is the value of this one? 1 by 2 power 3, correct? Because 2 power minus 3 can be written as 1 by 2 power minus 3 and 1 into not required, because anything multiplied with 1 will give you anything only, right? So 1 by 2 power 3. 1 by 2 power 3 is how much? 1 by 8. What is the value of 1 by 8? 0.125. So this is the procedure for converting a fractional part into binary. Now I will take another example and I will tell you. 0.6. Now the requirement is I want to convert 0.6 into binary. First step, what I need to do? 0.6 into 2 I need to do. Whenever I am doing 0.6 into 2, what value I got? 1.2 I got. What value I got? 1.2 I got. If I get 1.2, what value I need to take? 1. So I need to take 1 here. And remaining is how much? Remaining is how much? 0.2 into 2. 0.2 into 2 is how much? 0.4. Fine. Next, what I need to take? 0.4 I need to take into 2. 0.4 into 2 is how much? 0.8. Now we need to take 0. Next, what is remaining? 0.8. Okay, 0.8 into 2 is how much? 1.6. So what I need to take? 1. Now again I got 0.6 into 2. 0.6 into 2 how much? 1.2. Now I need to take 1. Have you seen here? 1.2 I took 1, 0.4 0, 0.8 0, 1.6 1, 1.2 I took 1 and 0.2 will come here. So have you seen? The number is repeating, means 0 0 1, 1 0 0 1 goes on up to infinite bits, correct? Means to represent 0.125 I require 3 bits, but to represent 0.6 I require infinite number of bits. Again I repeat, to represent 0.125 in the binary I need 3 bits, whereas to represent 0.6 in the binary I need infinite bits. Storing 0.6 in the infinite bits is of no use. Entire your hard disk will be filled with ones and zeros, and that ones and zeros are used to represent 0.6. To overcome this problem, one committee came. That committee is called IEEE754 Representation. So try to understand. To represent 0.6 we require infinite number of bits. If you take infinite number of bits, entire your memory will be filled with ones and zeros to represent 0.6. Instead of that, a standard committee came and they have represented in one standard way. That is called which committee? IEEE754, and they are going to call it as standard floating point representation. They are going to call it as what? Standard floating point representation. So try to understand, float data is not directly stored in binary. Double data is also not stored in binary. Okay, they converted into one standard form. What is that standard form? IEEE754 standard form. Why? Already we discussed, because I don't want to go to infinite bits, I need to make it as a finite. To make it as a finite only, we are doing this representation. First I will explain what is a representation. So now try to understand float. What is size of float? 32 bit. Try to understand. Now this 32 bit, how they are divided, you need to know. Okay. First 1 bit. This is how much? 1 bit. It is called signed bit. It is called signed bit. If this bit is 0, number is positive. If this bit is 1, number is negative. Next we have 23 bit. Okay, this 23 bit is used to represent fractional part. This 23 bit is used to represent fractional part. So 23 plus 1, how much? 24, and remaining 8 bit is used to represent integral part. Okay, and integral part is not directly represented. There is some other standard that we are not discussing because it's not in this scope. So, and it is called mantissa. Sorry, this fractional part is called mantissa, and this integral part is called exponent. Okay, this is called signed bit. So in the float 32 bits are there. The 32 bits are divided into 3 parts. First is a signed part, another is an integral part, another is a fractional part. Fractional part is called mantissa and integral part is called exponent. Why is it called exponent? We are not discussing in this video because it's not in our scope for now. Okay, and 1 bit is a signed bit. Well, now double. What is size of double? 64 bit. We discussed, right? Float size 4 bytes and double size 64 byte. One bit for signed bit. Well, 52 bits for fractional part. So 52 plus 1 will give you what? 53. 53 should be removed from 64. That will become how many? 11 bits. Is for exponent. Integral part. Okay. Now, if you can see, when we are using 52 bits to represent a fractional part, then it is called double precision. When we are using 23 bits, it is called single precision. Okay, now we will understand what is precision. Number of bits required to represent a fractional part is called precision. Number of bits required to represent a fractional part is called precision. If we are using 23 bit, then it is called single bit precision. If we are using 52 bits, then it is called double bit precision, double precision. Well, this is the difference between float and double. Then how do you understand whether a given number is a float or double? That's what we discussed earlier. If you write 3.75, this is double. If you append f, then it is considered as what? Float. Any decimal point number by default is considered as what? Double. Okay. So, for fractional part, if you are using 52 bit, more accuracy you will get. If you are using 23 bit, you will get less accuracy. So, when you want to deal with more accurate data, then you need to go to double. If you want to deal with less accuracy data, then you need to go with a float. Well, now we will see the previous example. First 0.125. What is the equivalent value of 0.125? 0.001 followed by some zeros. This is what in double. And 0.125f. This is what, anyway, here all zeros will be there. 0.001 and some zeros will be there here. This is float. This is in how many bits? 52 bits. This is how many bits? 23 bits. Well, when you assign 0.125 into f, first 23 bits are copied. Remaining bits are not copied. Have you seen which bits are not copied? There is only 0. When there is a 0, there is no precision loss. When there is no precision loss, internally in f, same value stored. That is the reason when you write f equal to 0.125, you got answer as what? Hello. Try to understand. Again I am telling 0.125 is a double. So how binary representation for double? 0.001 followed by so many zeros. Why? Already we discussed that, and it is in 52 bits. 0.125f is what? Float. 0.001 followed by some zeros. This is of 23 bits nature, this is of 52 bit nature. When you assign double data to float variable, first 23 bits are copied. First 23 bits copied means remaining bits are lost, right? That bits are anyhow zeros only. So when zeros are lost, nothing is lost to us. That is the reason there is no precision loss. In the f also we got 0.125. Now I will take another example. I wrote f equal to 0.6. Do you remember? If not, go to previous minutes. Well, 0.6 is what type? Double type. How it goes? 0.1001, 1001, 1001 goes on. This is of 52 bits. Well, next, when you assign, f is what type? Single precision type. Why f is single precision type? Because f is float type. What happens? I need to copy only first 23. Assume this is the first 23 bits. When you copy first 23 bits, this data is lost. The data which is lost here, definitely some months are lost here. When some months are lost, definitely some value less or more, some value lost is stored, right? So whenever we are assigning a double precision data to a single precision variable, there is possible precision loss. I am telling possible. Possible means what? It might or it might not. Here precision loss is happened, here precision loss is not happened. That really depends on the what value you assign. Later, f equal to I wrote 0.6 comparison. You are trying to compare a double data with f. Here precision loss happened. Definitely in f 0.6 is not stored. Some other value stored. That is the reason you are going to get answer as what? High. Finally, the overall conclusion what you need to remember is never try to assign a double precision data to single precision variable because there is a possible precision loss. Make sure whenever you are trying to perform any comparison, everything should be either float or everything should be either double. Float, size, 32-bit. Next, range, minus 3.4 into 10 to the power of 38 to 3.4 into 10 to the power of 38. Next, format specifiers, percentile F, percentile E, percentile E, percentile G, percentile G. Examples. Examples are little important. 3.5. What type? Double type. F. Float type. Minus 7.261. What type? Double type. F. Float type. 18.269, 263, whatever it is, F. Minus 2.512, F. These are all float type. Next, we have another data type, double. What is the name? Double is a data type. Size is 64-bit. And your range, minus 1.7 into 10 to the power of 308 to 1.7 into 10 to the power of 308. Format specifier, little interesting, it's not percentile D. Why? Because percentile D is always there for integer. Olden days, the double was represented using long float. That is the reason the format specifier is LF, LE, LG, LG. Examples same, 3.5, 18.263, minus 7.261, minus 2.152. Have you noticed these examples? Well, here F is there, here F is not there. That's what. Next data type is long double. Well, size is 80-bit and the range is 3.4 into 10 to the power of 4932 to 3.4 into 10 to the power of 4932. Format specifier is percentile LF, LE, LG, LG. Now 3.5 is what type? Double type. L, long double. 18.263, what type? Double type. L, long type, long double type. So that is what the ranges, and one important point you need to know is the ranges which we have mentioned and the size which we have mentioned are dependent on the machine. What I mean to say is the size of the float, double, long double sometimes will vary from machine to machine. If they are varying, then how do you know the size? For that only we are having size of operator. At any point of time for a given data type, if you want to find the size, we use size of operator. That will be discussed in the next videos.